Hi everyone. In this series, we are going to uh, solve this particular question, which is from trigonometry. F of x is equal to cos square minus 3 sine square x, and x ranges from 0 to pi. First part, we need to find root of f of x is equal to 0. And in second part, we need to find the derivative of f of x and also the coordinates of the points on f of x where f dash of x is 0. Then at last we need to sketch the graph. So this is quite extended question and let's get started. Totally 20 mark and first part is simple, just a 5 mark. Just solving an trigonometric equation stuff. We can apply ASTC rule and that will be so simple. So cos square x minus 3 sine square x, you convert into a single equal 0, convert into a single trigonometric function, either cos or sine. Okay, here I'm going to change into completely cos. So we know the identity sine square. So let's focus on like sine square plus cos square equal 1. Actually, x will come equal 1. So sine square can be replaced with 1 minus cos square x. So cos square x minus 3 times sine square x is 1 minus cos square x is equal 0. So cos square x minus 3 plus 3 cos square x equals 0. And 3 cos square x and this cos square x will become 4 cos square x minus 3 equals 0. We can simplify them like factorize them, or we can just go with another trigonometry identity. Okay, so I can take 2 cos square x like cos 2x. Since it's a square function, let me try to make it into a normal function like this. Okay, so factorization, I think that will hold. I can write it 2 cos x the whole square minus root 3 square equals 0. Okay, so now we will have, we can split it into factors. 2 cos x minus root 3 into 2 cos x plus root 3 equals 0. And let me equate it. So 2 cos x minus root 3 equals 0. First factor, if you equate to 0, and we got a simple cosine equation. Root 3 by 2, or 2 cos x is minus root 3 from the second factor, and cos x is minus root 3 over 2. Now, using the ASTC rule, where the cos is positive root 3 by 2, so the reference angle for root 3, it's very simple. Cos inverse root 3 over 2. And the cos inverse root 3 over 2 is pi by 6. At cos 30, it will be. Right? So reference angle I got, it's pi by 6. Now solving them, positive cos root 3 by 2 if you solve, like where cos is positive, here and here all are positive. So here whatever, just reference angle, theta is your answer. Here 2 pi minus a reference angle, minus theta. So our answer is going to be x is equal to pi by 6 only. Why? Because I'm solving this particular problem only for from 0 to pi. So in that, only one solution is possible. So we took that. So this is not needed. X is equal to pi by 6 for an answer. Here also the same reference angle will hold, but minus. So in the first two quadrants, here a minus comes. So this angle can be written as pi minus reference angle. So here you will get x is equal to pi minus pi by 6, which is 5 pi by 6. That's it. These are the roots of f of x is equal to 0. Let's conclude it. The roots of f of x is equal to 0 or pi by 6 and pi by 6. That's simple. This is the first part. And we can go with the next. So very simple. A normal factorization and a one single trigonometric identity we apply, and then a factorization using the basic identity. Then solving simple trigonometric equations using the AST0. That's it. We got it. Now the next part. Find f dash of x. Also find the points on which f dash of x is 0. And our points that we are finding should be on f of x. That's the condition. Let's go ahead. What is f of x? Let's copy that. It is cos square x minus 3 sine square x. Wait. And our x lie between 0 to pi only. Right. So f dash of x, the chain rule, right? It's quite simple. F dash of x is, first you apply the power rule, like 2 cos x times, what is cos x differentiation? Minus sin x. Minus 3 sin square x is also the same. 2 sin x times sin x differentiation is cos x. Okay. And let's simplify. It is going to be minus 2 cos x sin x. And here minus 6 cos x sin x. Totally it will be minus 8 sin x cos x or cos x sin x. This is familiar to an identity, right? That's why I write in this way. So that's simple. In order to simplify it, like one single function is what we are aiming for. So f dash of x is equal to minus 4, let me take out, and you can write 2 sin x cos x. And this is actually an identity. 2 sin x cos x is sin 2x. Let's replace it. So minus 4 sin 2x. This is the most simplification we can do for f dash of x. And hence, we got f dash of x. One part is over. Find coordinates of points on f of x where f dash of x is 0. So let me equate f dash of x is equal 0. Minus 4 sin 2x equals 0. So when a minus 4 goes there, it's sin 2x is equal to 0. Okay. So how to solve this? 2x is equal to, we know when sine function will become 0, right? When it is 0, pi, 2 pi. Okay. So sine of a function x will be 0 when x is 0, pi, 2 pi. And then sine 2x will be 0 when x is 0 by 2, pi by 2 and 1 by 2. So just you divide it by 2, right? Because I have an x 0 pi. If you have a double the x, so this 2 will go divided by 2, right? So 0 by 2, pi by 2 and 2 pi by 2, which is x is equal to 0 or pi by 2 or pi. So in this case, f dash of x is 0. Okay, so points on f of x. For these points, the f dash of x is 0. Now we need to find points on f of x. Points on f of x. Y is equal to f of x. So I just list what is my y. It is not this, not f dash of x, go to f of x. Cos square x minus t sine square x. And a basic substitution will help us. So when x is 0, what is y? Cos square 0 minus 3 sine square 0. Cos square 0 is 1 minus 3 sine square 0 is 0. So it's just 1. And we got a point 0, 1. is a point on the graph where f dash of x is 0. And x is equal to pi by 2, y equal to cos square pi by 2 minus 3 sine square pi by 2. Cos square pi by 2 will be 0, right? Minus 3 sine pi by 2 is 1. So it's minus 3. And we got this particular point, which is pi by 2 comma negative 3. And last point, x is equal to pi. When x is pi, y is equal to cos square pi minus 3 sine square pi, which is cos pi is going to be positive, no, negative 1, right? Minus 3 sine pi is 0. So 3 times 0, it's just minus 1. And this point is pi comma negative 1. So this is the answer. We find f dash of x, and also we find the points on the graph where f dash of x is 0. These are the points. That's simple. And next one, sketch the graph modulus f of x where f of x is this. Right. So let's get into that. First, let's try to simplify, convert to single function. We already have simplification somewhere else, maybe in the first part, I think so. F of x, the simplified version is 4 cos square x minus 3 equals 0. Right? So we can choose this. So f of x is 4 cos square x minus 3, and the same domain. 0 less than or equal, less than or equal 5. Sorry, pi. Okay. First, let me look out for the range of the function. Okay, I know cos x will lie between minus 1 to plus 1. What happened when I square it? So whenever a thing squared, the minimum is 0, maximum is, according to that function, it's 1. And 4 cos square x, if you multiply by 4, it ranges from 0 to 4. And 4 cos square x, subtract 3 on all the sides. You will get 0 minus 3, which is minus 3, 4 minus 3, which is 1. So this is the range. Your graph is going to lie between minus 3 to positive 1. Okay. Now, absolute value. Apply the absolute value. This is for f of x, but what if it's my absolute value function? This is important. Okay, if y is equal to f of x means what is the work of mod y? Mod y reflects any negative part so in y, it might have above x-axis and below x-axis. If any negative part is there, it will reflect it to positive part. That is how the absolute value behaves. Okay. So any portion of like 4 cos square x minus 3 is basic function, but modulus of it, you graph the function completely. And the negative part, you just flip it over the x-axis. Okay. So, but to graph 4 cos square x minus 3, we need some parameters and key points. Let's go with that. So 4 cos square x minus 3 equals 0. And we already solved this, right? So cos square x is 3 by 4. Cos x is plus or minus 3 over root 3 over 2. And you will get x is equal to 0 to pi we are solving. So it's either pi by 6 or 5 pi by 6. This we already did. It is just a glimpse of it. Okay, this will be useful. So the function will cross the x-axis. These are the x-intercepts. Okay. So your graph should touch x-axis at this point. And this is also they particularly mentioned. So in your sketch, you have to show those stuff. like and any points where the graph meets the coordinate axis, even y-axis if meet, we have to show that, right? And we did the positive x-axis stuff, and let's get into that next part. Okay, next is finding the critical points, right? So the critical points are, since I got a pi by 6 as my intercept, so I have to divide them into like x-axis interval, you can divide it into pi by 6 to pi, like in the interval of pi by 6. Okay, and no negative part, right? So we can just focus on the first quadrant alone. Okay, how I am going to divide this is into pi by 6. So when I divide it into pi by 6, I will get 0, 30, 30, right? Pi by 6, pi by 3, pi by 2. In that way, I need to split, and I have to find all the respective coordinates. So this is the way I am going to do. Like this 0, this is my pi by 6, then a pi by 3, then pi by 2. Then it is pi by 2 plus pi by 6. It is going to be 2 pi by 3. 5 pi by 6. And then again, if you add a pi by 6, you will stop at 1. Okay. And these points we already come across, pi by 6, 5 pi by 6. The graph will cross the x-axis. Let me make an into mark over there. So it will cross the x-axis. Okay. When you're drawing the graph, it should cut here. And okay. So what about pi by 3? When pi by 3, what is the y value? When pi by 2, what is the y value? So I know the range also, right? It's from -3 to +1. So from 0 to +1 is more than enough. Like this is 0. Let it be 1. Oh, wait. Okay, maximum, minimum we need to find. Just a second. So maximum of the function is +3, right? Because -3 is a point in our range. We have that bar here. But while we are reflecting that -3, +3 will be there. So you can take your values from 1, 2, 3 like this. Till 3 is fine. Okay. And finding the key points are important. Almost all the parameters, so good. So into the key points, we can just substitute the values. X is equal to pi by 6 and 5 pi by 6. I know when x is 0, what is your y? Y is modulus. Don't miss it out. 4 cos square x minus 3. And we can just substitute and check those values. 4 cos square 0 minus 3. Equal cos 0 is 1, right? So modulus 4 into 1 minus 3, 4 minus 3, which is 1. So 0, comma 1 is a point. When x is 0, it is 1. We can mark that. It worked. Yeah. So when x is pi by 6, I know it crosses x-axis. When x is pi by 3, we can jump. Y is equal to modulus 4 cos square pi by 3 minus 3. So cos square pi by 3, like cos pi by 3 is 1 by 2. Cos square pi by 3 is 1 by 4. So 4 into 1 by 4 minus 3, which is 1 minus 3, which is 2. So when it is pi by 3, it is 2. Then at pi by 2, it is maximum. This one, we did it over here, right? Where it is, yeah. When it is pi by 2, actually it's -3, but we are reflecting it, right? So in that case also we can do, otherwise substitution also will work. When x is equal to pi by 2, y is equal to modulus 4 cos square pi by 2. Cos at odd multiples of pi by 2 is 0. So it is modulus of -3 and it is +3. So it is pi by 2, it's 3, let's mark it. We can do all together and then we can do it, but anyways, let's go like this. Here it is. Then it's symmetrical. So I know the next point is this, the next point is this, but anyways, let's do. When x is next point pi by 2, after pi by 2, 2 pi by 3. Y is equal to 4 cos square 2 pi by 3. 2 pi by 3, it's obtuse. Okay, anyways, it's a square, right? So pi by 3 is 1 by 2. Again, it's 4 times 1 by 4 minus 3, which is 2. And your values will be symmetrical. So it's 2. Again, at 2 pi by 3, it's 2. At 5 pi by 2, it's 0. We know that. And then at pi, it will be 1. Anyways, we can substitute and check. So when x is equal to pi, y equal to modulus 4 cos square pi minus 3. And I know cos pi is -1, squaring it plus 1. Modulus 4 minus 3 is equal to 1. And yes, 1. That's it, 0 to pi. We have the structure. And let's draw the sketch. So it's 0, then it goes to, okay, let me choose better color. From here to here, and then from here it raises, and it goes like this. Okay, it should touch anyways. And then it should come again and go over there. Okay. So this is my y is equal to modulus f of x complete sketch. And all the parameters, key points, everything is mentioned clearly. So that's the graph. And this completes the 20-mark question. Thank you so much for listening.